Hey there, and welcome. Today, we're going to talk about something that's literally all around you. I mean, look around. From tiny tiles to massive buildings, they're all built from these fundamental geometric shapes called polygons.
All right, so let's start with a little riddle. What in the world could a beehive possibly have in common with the Pentagon? I mean, one's made by insects, the other is, well, the Pentagon. They seem like they're from different planets, right? But believe it or not, they share this really cool geometric secret.
And you guessed it, they're both built with polygons. A honeycomb is just a beautiful collection of hexagons, and the pentagon is, well, a massive pentagon. It's kind of wild when you think about it. These shapes are absolutely everywhere, and today we're going to figure out exactly what makes them tick.
So, let's get into it. What makes a polygon a polygon? Think of it like a members-only club. It might sound fancy, but the rules for getting in are actually super simple. But they are very, very strict.
Okay, so what are these rules? Rule number 1, the shape has to be completely closed, no gaps, like a fence that keeps everything inside. Rule number 2, it's got to have all straight sides, no curves, none at all. And rule 3, the sides can't cross over each other. They can only meet up at the corners, nice and tidy. Break any one of those rules, sorry, you're not a polygon.
And that right there leads us to the textbook definition. The most important things to remember are that it's flat, so two-dimensional, it's closed, and it's made of only straight lines. See? Pretty straightforward. That's the basic DNA of every single polygon we're going to talk about.
Okay, so once a shape is officially in the Polygon Club, how do we start telling them apart? Well, the simplest way is just to count the sides. Seriously, the name of a polygon is basically a cheat sheet for what it looks like.
So here's the classic lineup. You've got 3 sides, that's a triangle. 4 sides, a quadrilateral, like a square or a rectangle. 5 sides gives you a pentagon. 6, a hexagon. It just keeps going. The name tells you everything. An octagon, like a stop sign, has 8 sides. A decagon has 10. It's a pretty handy system.
But wait, there's more. Counting sides is just the first step. We can also categorize polygons by their shape, their posture. Are all the corners pointing out? Or does it look like it's got a little dent in it?
Here's a really simple test you can do to figure this out. Just imagine picking any 2 corners on a polygon and drawing a straight line to connect them. Where does that line go? Does it stay inside the shape? The answer tells you a ton about what kind of polygon it is.
This shows the difference perfectly. With a convex polygon, any line you draw between 2 corners stays completely inside. All its corners are kind of pointing out. But a concave polygon, it's got that inward dent we talked about. It looks like it caved in on itself. That dent means it has at least one angle that's bigger than 180 degrees, and because of that, you can draw a line between 2 corners that actually goes outside the shape. Kind of weird, right?
All right, on to our last way of classifying these shapes. This one's all about balance and perfection. Is the polygon totally symmetrical and uniform, or is it a little, lopsided?
Just look at these 2 triangles. On one side, you have a regular triangle. See how perfect it looks? All the sides are the exact same length, and all the angles are the exact same size. It's just neat. But then you have an irregular one. Its sides are all different lengths, the angles are all over the place. It's still a triangle, but it's not as uniform.
And this is the super important part. For a polygon to be called regular, it has to check 2 boxes. All its sides have to be equal, and all its angles have to be equal. If it only does one, or neither, then it's an irregular polygon. No exceptions.
So now that we've got all the rules down, let's zoom in on 2 of the most important polygons out there. I'm talking about the true MVPs of the geometry world, the triangle and the quadrilateral. For triangles, this is the magic number, 180 degrees. It doesn't matter what the triangle looks like. It could be tall and skinny, short and wide, regular, irregular, doesn't matter. You add up its 3 inside angles and you will always get 180 degrees. Every single time. It's a fundamental rule of the universe.
And for any 4-sided shape, any quadrilateral, that magic number just doubles. So for a square, a rectangle, a trapezoid, whatever, its 4 inside angles will always add up to 360 degrees. Simple as that.
So why do we care about these magic numbers? Well, because that predictability is their superpower. It's why triangles are so strong and why engineers use them to build bridges. It's why architects can rely on quadrilaterals to make buildings that stand up straight.
This mathematical certainty is what makes them, without a doubt, the most important building blocks we have.
Okay, so from now on, you're going to see them everywhere. That octagonal stop sign on your street corner, the hexagonal tiles on the floor. Polygons are hiding in plain sight. Now that you know all the rules of the club, I've got a challenge for you. What's the most complex or maybe the most interesting polygon you can find in your world today? Take a look around.